Resolving forces. When we resolve forces, we pick two perpendicular directions. So if we're looking at a system that's on a flat surface, we'll pick the horizontal and vertical direction, and these directions are perpendicular to each other. A system on an incline, we can use the direction parallel to the incline and a direction perpendicular to the incline. So these two directions are perpendicular to each other. And resolving a force means we're going to break it down into two component forces at right angles to each other. A force is a vector, so it has magnitude, the size of the force, and direction. On a diagram, the direction is given by the arrow. In an equation, we use signs, plus or minus signs. So let's take this example. Both of these forces are acting on this particle. These two forces here are perpendicular to each other. The triangle law of forces states that the resultant effect of these two forces can be represented by the third side of this triangle. The magnitude of this force is 5 newtons from Pythagoras' theorem. So now these two forces can be replaced by this single resultant force, like this. Resolving this 5 Newton force into two perpendicular directions is doing the exact opposite of what we've just seen. So we start with a right angle triangle, and we need to work out these two missing values. And typically the angle here is given, and using that angle we can work out the two missing sides. We check the direction of the arrows to make sure they're correct, so the 5 Newton force starts here, ends there according to that arrow, and the red and blue arrows do exactly the same. They start here and end here. We can now replace the 5 Newton force with these two forces which are perpendicular to each other, like this. We resolve a single force into two forces perpendicular to each other to aid problem solving. If the resultant force in any direction is 0, we have equilibrium or balanced forces, which is essentially Newton's first law, and the acceleration will be 0 in such cases. If we do have a resultant force, for example 5 newtons, then we can use F equals ma from Newton's second law of motion, and this can be given in vector form as well, like so.